This project is about Cobot digital twin design for smart maintenance. So, what's a digital twin? Digital twin is like a virtual model, and one may think, what's the difference between digital twin and a typical simulation model? Well, most time when we develop a digital twin, we are looking at developing a high fidelity model, and at the same time, this is a type of model that is being updated constantly. That is, you don't just develop it once and leave it like that. You need to update the parameters of this kind of virtual model as the physical system is changing. When it comes to Cobot now, in developing the digital twin, the structure we are proposing here is to have this framework that integrates elements like controller, the robot controller here, which could be a PID, the motor and gear dynamics, and of course the motor dynamics, including friction and some other things like disturbance. All right. And we can also have the Seascape model here, which contains the mechanical aspects of the digital twin, that is the links and how they connected from the base to the end effector. So, in terms of application now, our model can, that is our digital twin, can predict the the state of the system, such as the torque, which is a parameter that is very useful when it comes to smart maintenance now. And this can be compared with the output of the physical robot. And the error we're getting, the residual, can be further used in fault detection, fault diagnosis, and fault prognosis. Supposing we have three experiments. These three experiments, that is a UR10E cobalt with different payloads, 0 kg payload, 4.6 kg payload, and 11.9 kg payload. We can, through the help of Synscape, replicate the same thing. Uh, so we can have the card design of the different payload, and by developing our digital twin, we can have this kind of results. And you can see that the model, which is like a virtual model we have on the right, is uh, showing a behavior that is close. That is the dynamic behavior here is close to what we have on the right, which is the physical system. So the idea here is that if this model has been developed to be as a high fidelity model, right, where the information about the joints, such as the joints, motor model, the gear model itself, is included in the digital twin model. So we can use this in simulating different faults. And that's the beauty of digital twin. So that through that we can get uh, data that can be used in training AI algorithms, basically. And with this kind of project, there are a lot of opportunities. This can also be used in other applications like condition monitoring or remote monitoring of systems. So digital twin is a very interesting concept, and for a complex system like a robot, the digital twin uh, needs to take different elements into consideration. And we hope that as this project continue, we'll be able to do something more about the digital twin of a cobot, because this project is still at the preliminary phase.